Hello everyone, this is Eddie the Magic Monk. Today we're going to show you guys how to do a differentiation modeling and problem solving question that involves hyperbolas. Okay, so have a read of the question and come back when you're ready to see the answer. Okay, so it says a hyperbola can be used to represent the growth of a mouse after its birth. So as soon as you see the keyword hyperbola, write down the general formula for it. And the general formula is y equals a over x minus h plus k. Okay, that is the general formula for a hyperbola where a, h, and k are constants. Okay, they can just be any real number, doesn't matter what it is, but the key thing to remember is a, h, and k are constants. They're not a variable. Only x is the variable. X is the only thing that can change. A, h, and k, once you decide on what number it is, a, h, and k, they never change. Okay, so it says at birth the mouse was 10G and was growing at a rate of 6G per day. So there are two variables here. G obviously is the weight, so let y be the weight in grams and let x be the number of days. Right, so we can substitute in some numbers now. When x is 0, y is 10. So let's substitute those numbers in, and we have 10 equals a over negative h, right, because x is 0, 0 minus h is just negative h, plus k. Right, so we still don't know what h and k are, so let's go back. At birth, the mouse was 10G and was growing at a rate of 10G per day. We'll differentiate the function later. It grows to eventually almost 40 grams. So what does that mean? That means vertically the graph will not exceed 40 grams. So we're going to have to use a little bit of the concept of limits here. And the concept of limits is that as x approaches infinity, right, because it says it grows eventually to almost 40 grams. So that means doesn't matter how many days the mouse lives, the weight of it just gets closer and closer to 40. It doesn't get over 40. Right, so if you write this whole equation as a limit, the limit of this equation as x approaches infinity is equal to 40. So if you want to evaluate infinity limits, remember how we taught you guys how to do this earlier on. So we divide every single term in the fraction by x. So then we have a over x divided by x over x minus x over h over x plus k is equal to 40. And then, so we still have the limit symbol here because we haven't substituted it in. And then the next step is we substitute infinity into where x is, and any single term with x as the bottom of the fraction will turn into 0, because if you divide a number by a very big number, it turns into 0. So a divided by x then turns into 0. Divided by x is 1 minus h divided by k. Sorry, I made a little typo there. This is supposed to be x. And that's 0 again, plus k is 40. So 0 over 1 plus k is 40, so k is 40. So once we've established that k is 40, we can then write out this whole equation again, and it is equal to, so we can substitute 40 into here. So then it is equal to 10 equals a over minus h plus 40. And then if I rearrange that, move the 40 to the other side, it becomes negative 30 equals a over negative h. Rearranging this to make a the subject, I then have a equals 30h. And now I have an expression for a in terms of h. Then I can go back to my original equation, and that is y equals a over x minus h plus k. And I'm going to put 30h where a is, and x minus h, and k is 40. Okay, so now I just have one last variable to find, and that's h. And you can see here it's given us the information that the growth rate is 6 grams per day at birth. So if I differentiate this equation, I get the growth rate with respect to time. So y dash is equal to, and just before we get y dash, I want to rearrange y so that I have 30h bracket x minus h to the power of negative 1 plus 40. Right, using the basic index law that I can move whatever's on the bottom to the top if I make it to the power of negative 1. Okay, so if I differentiate this using the chain rule, if you guys remember how to use the chain rule, if you don't, have a look at the chain rule video. But basically, when you have brackets, you would put the power at the front of the bracket, so it becomes negative 30h bracket x minus h, and you would minus 1 in the power, so it's minus 2, and then you would multiply by the derivative of the inside of the bracket. Now remember, h is a constant, h is not a variable, so you treat it as a constant. So when you differentiate a number, it just turns into 0. So therefore the inside is just times 1. So the inside derivative is just 1. So if you times by 1, you don't have to write it. So that's the derivative of this whole thing here. And then this 40, if you differentiate it, it turns into 0 again, because a constant just differentiates to 0. So yeah, that's the derivative. So now if I rearrange that, I get y dash equals negative 30h over x minus h squared. Now the question says when x is 0, y dash, when x is 0, because at birth the number of days is 0, when x is 0, y dash is 6. So if I substitute that in here, if I substitute that in here, 6 equals negative 30h over negative h squared. And if I keep going with that, I get 6 equals negative 30h over h squared. The h and the h squared, you can cancel something, so it's negative 30 over h equals 6, so therefore h equals negative 30 over 6, which is negative 5. Okay, so if I go back to the original equation, which is this one, okay, let's put that over here, and we can now substitute everything we know. So y is equal to x plus 5 at the bottom. Now what does a equal? If you remember, a equals 30h, right? We figured that out before. So if h equals negative 5, a equals what was it? 30h. So a equals 30 times negative 5, which is negative 150. So let's put that over here. And k is 40, so we have an equation for our parabola. So pretty much finished. What was the question? Predict the mouse's weight after 30 days. So when x equals 30, y equals negative 150 over 35 plus 40. Put that in the calculator, and the answer is 35.71. Okay, and if you're interested in plotting this graph in the GeoGebra, I've already done that for you guys. So you can see here, this is our equation, negative 150 over x plus 5 plus 40. And you can see here, this is our line, and originally it is at 10 grams at birth when x is 0, and eventually the line just gets closer and closer to 40 on the y-axis. Okay, thanks for watching, guys. See you next time.